Bird species classification. Bird species classification by using deep learning and machine learning. For that, I did an application like this. In this, we have to upload an image of bird, any bird, and it will upload. It will predict the species of American goldfinch, details of the bird. Okay, I will explain everything after this. Let's start the topic. Birds play vital role in our ecosystem, from pollination to ecological indicators. Identifying bird species is essential for biodiversity conservation. In this video, we explore how machine learning and deep learning help classify bird species using audio and image data sets. Two different research papers were used for machine learning. First one is this bird clap to 2024 dataset with 182 bird vocalization was used. These audio files were proposed using male frequency septal coefficient to extract meaningful features. In contrast, the deep learning model used the culture's UCSD birds 200 dataset containing nearly 12,000 bird images. The images were converted to grayscale and processed through conventional layers. In the machine learning approach, three models were trained: k-nearest neighbors, support vector machine, and random forest. Another one research paper. This is meanwhile the deep learning method employed a deep convolutional neural network built using TensorFlow, capable of extracting fine-grained features like break shape, features texture, and bird posture. See, random forest delivered the best performance among machine learning methods, achieving an accuracy of 86.37 percentage, while KNN followed closely with KNN 86.12 percentage and SUVM 69.97 accuracy. For this, KNN has a precision is 0.8365, recall is 0.8592, and F1 score is 0.8461. For random forest, accuracy is 87.36% and precision is 0.8563, recall is 0.8719, F1 score is 0.8628. For SUM, accuracy got 69.97%. It's very less compared to both the other two models, and precision also 0.6912, recall also 0.6980, and F1 score also got less 0.6883. On the deep learning side, the proposed CNN model reached a remarkable accuracy of 89%, outperforming several existing techniques like post-norm and part-based RCNN. The machine learning based system even features a user friendly streamlined interface for real time audio classification, making it accessible to non technical users. On the other hand, the deep learning method excelled in visual identification, ideal for mobile or web based apps that use camera input. In this, methodology employed, how they applied, see user input the image file, then uploaded image file, then file store rdb, then after that field image, apply cnn from this train model, get train model, after that future extraction, then apply classifier, and it will get the result, show result. This research paper containing a database of 200 bird, that's cub 200 to 2011 database, and it contains 11,788 tagged photo of events. Okay, there are about 250 examples photograph per creature containing in the collection of 7 species that are physically caught in their native environment. See the graphical representation of score generated for this score, and also accuracy they got. Post norm RCNN, MGCNN, deep LAS, lack deep learning using CNN. Accuracy. C. Species and score generated. Species are Legend turn got 0.00921 score, and red faced cormorant 0.00929%, Brent cormorant 0.082, pelagic cormorant 0.085, white pelican 0.087. Second table contains comparative analysis. Force norm accuracy of 82%, part based RCNN accuracy of 78.2%, multiple granularity CNN 83%, diversified usual attention network DVA, that's DVAM 80%, the deep LAC localized algorithm and classification 82.7%, proposed method 89%. Okay, to overcome this, we built a model. We built a model. We had a dataset from bird species classification, which contained 200 categories. In this, they have different subfolders like this. The individual species containing their names, classification of bird species like Acadian flycher, American crow, American goldfinch, American pipit, like this. So many are there. Okay, and each of them having nearly 10 to 12 images are there. From this, we built a model which, which gives 100% accuracy. See the test accuracy of 100%. So say what we did in model, I will explain you. Required class name. the species has many classes. The bird species having many classes. They have namely like this. Okay, we took that individual and submitted in this. Then after that we did a argumentation, image argumentation, and in data balance, then pre-processing the data and preparation of the data and process and save with the subclasses, splitting the databases and including label, that's the mapping. See the image distribution by the class and class. This is the image distribution, number of images versus classes. Then this is the subfolders which having a class name individually. Acadian Flycher, American Crow, American Goldfinch, American Pipit, American Red Star. Then we did a model using efficient model in which we did epochs. About 20 epochs we did. 20 epochs we did. In this, early we got loss of 4.7267, accuracy of 0.0532, validate loss of 3.8642, validate accuracy 0.2630. After that, finally we got loss of 0.2015, accuracy is 0.9950, validate loss is 0.1457, validate accuracy is 1%. 1, that is 100%. And see the graph in which training validation loss versus epochs and training and validation accuracy versus epochs. See, and we got a test accuracy of 100%. 1 means that's 100%. And see the confusion matrix. After that, we had an original image and grade cam head map and head map overlap. This type of model we built by using the dataset, and for this we did an application. Okay, in application, birds classification detection using histopathology images. Upload clear images. So our service gives bird classification detection using histopathology images. We can able to classify the bird classification, which I have shown earlier only. Okay. In this we will first upload. I will type upload here. Please upload the image, clear image, so that we can identify which type of species is. Okay. Choose the file. Let select this one. Okay. Upload. Okay. Predict the name of the species. See. Acadian flycher. Bird details. Acadian flycher bird name and details. Prepare mature deciduous forests, sensitive to habitat fragmentation. Let's see another one bird. Choose the file. Okay, select this one. Okay, uploaded. Now predict the species. American crow. Bird details. American crow and details is highly adaptable. Means it will adapt everywhere. Travels in both urban and rural environment. We can see here in anywhere crow. Another one. Let's see another. Let's upload another one. Okay. Predict the species name. American goldfinch. Bird detail. American goldfinch name of the species and details is primarily seed eaters. They will eat the seeds and nest layer to align with testal availability. Let's say another one and we will finish it up. Bare breasted warbler details migrates between boreal forest and South America. Color varies sensibly. Means its color will be variable according to ecosystem. Okay. If you have any doubts regarding this model, you can contact us. We will suggest you so that you can come to learn. We will give you the code and everything for this model. We have, can you please contact us through the our website which is mentioned in below. Thank you very much for watching this video by patiently. Thank you.